Okay, we're going to make a start now. So we have Toby McBride to talk about blood, sweat and tears and electric solar cars. So without further ado, I will hand over to him.
Thank you very much indeed. Good afternoon, everyone. Thanks very much for joining me and being here today. It's a lovely day and great to be here at what I term Glastonbury for Geeks in Guildford. It's a fantastic festival. I've been wandering around for most of the day and looking at some of the stands and workshops. It's been great to be here. So I'm giving a talk, actually, it's blood, sweat and carbon, not blood, sweat and tears. This was a phrase coined in Australia by the team. And it's really going to give you, this presentation is going to give you an overview of how we actually designed, we built and raced this solar car. It's a pretty incredible feat. We're all students at Durham University, including myself. I'm moving into my third year now. And we've got a very exciting time ahead. So I'm going to give you a glimpse into our past and a very exciting future ahead. So let's begin. So we are a student-led and student-run team, as I said, and we're a mixture of undergrads and postgrads, all doing this in our free time. So we're a mixture of anything from engineers, normally, to business students, marketers, and think of any type of degree, and we have one. And as I said, a variety of degrees, and it's entirely extracurricular. So although at university you all think, yep, you're going down the pub for a drink, no, we are actually doing this in our free time. So we have a fair bit of free time at university, and we like to do this. What about the team history? Well, we actually are the longest running team to do this. We were founded in 2002, and we built our first solar car in 2004. Now, a lot of you probably won't have seen a solar car before. Some of you may have, and I'll show you a picture of one in a second. It's a very unique design. It's basically a table with solar panels on. That's what people often say to us. Why is there a table at a motor show? Or why is there a table here today with solar panels on? It's a very unique design, and we built our first one in 2004, so quite a while ago now. We then took this car and we raced it across America. Now, this is a race called NASC, North American Solar Challenge. And we raced this, it's 2,500 miles. So it's not like a test track where you race and see who's got the fastest time, star in the reasonably priced solar car or something. What it is a 2,500 mile race all the way across America. And we actually won what's known as the Best Rookie Team award, which we liked. In 2011, we took this car and enhanced it a great deal. We built a lot of new refinements into it, and we raced it across Australia this time. So another big challenge. This was 3,000 kilometers, so no mean feat, 1,800 miles in that form. And actually, we were known as Durham University Solar Car. We're now merged with the Formula Student team. Many of you have heard of Formula Student, of course. Our primary focus going forward is on solar cars, but we do have a Formula Student attribute to the team as well. So this is the car itself in 2008. Pretty unique looking. If there's any Americans amongst you, anyone knows the Jetsons, that's what we kind of like to think it looks like. Very futuristic, very different indeed. And that's it driving along normal highways, everyday roads. Really, really cool and a big challenge for us. So we're driving at highway speeds. Here's some more shots of it, us doing some testing before the race actually began. And we also have, again, another shot of us on the road. So this car could do about 50 miles an hour or so, pretty fast. Had 3 wheels, as you can see there, steel subframe chassis with a carbon fiber top. Now, here's the actual pit garage at the event. You can actually see us. We are next to that big white trailer. We haven't got a big white trailer at the time, but we had humble beginnings, and that was us there with a low loader and a van. But we still did very well, the best rookie team, so a great award for us to win. And still, 2,500 miles, a big distance. Now, we took this car, and we enhanced it. We made it longer. We made it lighter. This is us with a 6 square meter array driving across Australia with the infamous canopy bouncing along. That's for ventilation, I should point out. Obviously, clearly it is. And this is us on the just coming along the Stuart Highway, which is the main road that runs from Darwin in the north all the way down to Adelaide. So that's 1,800 miles. It's a big distance, and that's us actually finishing in Adelaide. So that's the car. Again, similar design to the one previously with a few upgrades. Now, most of you think, what on earth's happened here? Has this car fallen over? No, what we've actually done is tilted it on its side. So we race from 8 to 5 during the day. And in the morning and in the evening, we have an hour to charge up the batteries. And that's what we do. We point it at the sun, and we managed to collect the last bit of charge for our batteries to drive the next day. And again, there's another shot of us there, just going across the tropics. And that's us in the pit lane. And about 40 teams do this, so it's not like it's a small event. There's millions of dollars invested in this, and I'll go on to that later on. Now, what's the point in all of this, you may be thinking? What's the point in designing, building, racing a car that works in the sunshine, but you think, why are they developing in Durham? I mean, Durham's freezing cold and wet. That's a bit ironic, isn't it? Well, we've got a very exciting future ahead, and we have 3 key arms to this. We're showcasing the latest technology. It's all about proving to the public, it's proving to ourselves that this technology can work in any conditions. It's educating the public. It's saying to the public, look what solar power can do. We can drive infinitely. As long as the sun's shining, we are driving. And it's also inspiring the next generation, because we do a lot of outreach to schools. We'll take this to schools across the UK when we go to major events and say, become engineers, think differently as to how to build things, and think differently about our planet. Now I'm going to walk you through our brand new car. Our new car, well, it's unlike anything we've ever done before. It had to move to a 4-wheel design, and we thought we could just add a 4th wheel to the existing one. That's fine. Actually, you probably now see me. I've got some lights. Brilliant. We could have done that, but we thought we'll start from scratch. So over 3 years of design and development, we built this car. This car has a 4-wheel design, 6 square meter array, and is unlike anything we've ever done before. Now, this car itself, we thought, well, we're going to have to make it better, obviously, because we're doing well. We qualified in the top 10 in 2011, had some technical issues, but we did well. We can do better, though. We can do better with our plucky British spirit. So we can do 40% faster top speed than our existing car. That's 70 miles an hour. 70 miles an hour in a car that is 5 meters long and 2 meters wide and weighs a third of the weight of the previous car. That's 200 kilograms. It's an unbelievable feat of engineering and a true triumph for our team. So how do you actually build one? How do you actually do it? What does it take? Well, I'm going to walk you through 4 key areas. First one is aerodynamics. We've got to make a car that's streamlined to make sure it cuts through the air in the most efficient manner. We've got to make a car that's very sound structurally, that's very light and strong. And that's why carbon fiber comes in. The electronics are a key part. We can build a car that's very aerodynamic. We can build a car that has a very good structure. But if we've got something that goes as fast as a milk float, we've gone backwards. So we need the best power output with the most efficiency. And that's where the electronics comes in. And finally, we need the business side of things. We are entirely student-run and led. We are financed through sponsors and private donors. And we have actually probably one of the lower budgets of any of the teams out there. As an example, our budget for this coming year is about 100,000. Michigan have $4 million. A team in the Netherlands, I believe it is, has $28 million. So we are the plucky Brits doing this in a shed in our free time, but we do very well. So let's walk through this. The first thing is aerodynamics. This is a CFD model of our car. As I said, it spent 3 years in the design and development stage. And it's a truly groundbreaking design, an asymmetric design. Now, when you add a 4th wheel, that's fine. Where do we put the driver? Well, we could put him in the middle. Makes sense. But actually, you add aerodynamic drag, you add weight, because we've got to make the center of the car stronger. We have no longer got a third wheel in line. So we moved him to the left-hand side, in between the wheels. Why is the left-hand side, not the right-hand side, when Australia drives on that side? Well, it's actually to cast the least shadow on the solar panels. We're driving 4 hours in the morning, 5 hours in the afternoon, evening time. And with those conditions, we cast the least shadow by putting the canopy on the left-hand side. As I said, we sit between the front and rear wheels, and we've also got some innovative suspension, double wishbone at the front and a trailing arm rear suspension at the rear to make sure it's incredibly light. We're actually moving to carbon fiber suspension as part of the upgrades this year. So really exciting time for us. The area of the car that actually hits the air itself is less than a square meter. Less than a square meter. That is unbelievable for a car of this size. To make it strong and light, it's very difficult. And now what I'm coming on to is the structure of the car. Now, we've got a big team at Durham who are now pretty much experts in the area as to how to build a car from scratch out of carbon fiber. This has never been done before by us, to build an entire car. We've done bits and pieces, a meter squared, let's say. We've never built a car that's 5 by 2 meters. So how do we actually do this? Well, I should also point out that we use 5 times less power than a Prius when we're cruising. How do we actually manage this? Well, let's go through and look at it. We first of all create molds. This is a CNC router, cutting the molds out of model board in order for us to make the complex shapes needed to construct the car. So we form layers of these, we build them up, and this is part of the process at Southwest Durham, just down the road from us. They gave us this machine, said, you can have the machine, one problem, it's broken. So you need to fix it and then build the car. So we actually fixed the machine and built the car from scratch. One of the only teams to do this. Most teams just say, oh, Ford, you're now down the road from us, Michigan, build the car for us, thanks very much. So we built the car entirely from scratch. And this is what we ended up with for the molds. So we then created an oven in order to heat the carbon fiber up and get the epoxy to set when we put the carbon fiber in. But when you obviously build carbon fiber, you've got to make sure it seals and is correctly formed. And to do that, you've got to create a vacuum. And to create a vacuum, you need a bag this size, probably about the length of this room. It's a big lecture theatre we got there at Durham. Oh, sorry. It's a pretty big lecture theatre we got at Durham, and that covered all of it. So if there's one tear in the bag, we've had it. We've got to make sure that the seal is optimal across the entire range. And that's a key part of our layup and building of the structure. It's a really interesting part of us. Again, we'd never done this before, and yet we created a car that is very lightweight and very strong. Moreover, when we look at the structural side, we also think about safety for the driver. The rules are, excuse me, the rules are very specific, and they say you've got to survive a certain impact. So we actually reinforce the side of the car and the front of the car with Kevlar. That means that we've got great shatter resistance. So when, God forbid, if we did have an accident, the carbon fiber doesn't shatter. Incredible innovation there that we came about with. So that's the structural side. That's the mechanical side. What about the electric side? What about the powertronics of the car? Again, we need this to go fast, but on very little power. So we've got a really innovative new motor that we've designed and built from the ground up. We're moving on to, I think, our 5th generation motor the next time that we go to Australia. And it's an in-wheel motor. It's inside the hub of the wheel. There's no separate gearbox, drivetrain, chains, anything inside the motor itself. And that means we've got incredible efficiency and we've got incredible top speed as well. As I said, we have now got our 2nd generation of this particular form of in-hub motor. Overall, it's our 5th one that we're building. And we designed this ourselves and built it ourselves. We're the only team in the world to go, well, let's build our own motor, rather than going and getting one and buying one. So we actually built and designed it from the ground up. And that's enabled us to optimize it to around 94% efficiency. We're actually looking at increasing that towards 98% going forward. So that's an incredible efficiency for us. And the total output is around about 5 kilowatts we're looking at. Now, that's about what you run on a sort of kettle or similar. So we're not using that much power, but we're still doing 70 miles an hour. So by no means is it going to set any world records for 0 to 60 time, but it's only going to set world records in, the longest distance, shall we say, you can travel. Now, what about the actual electronics themselves? Well, we've designed ourselves a battery management system. We've got maximum power point trackers, MPPTs, to ensure the solar panels are operating at their best. We've got the solar cells and driver management tools. So we've completely designed these from the ground up ourselves, and we've recently partnered with Sevcon, just up the road in Newcastle, to assist us with this as well. We've also got really clever telemetry. So when we're driving across Australia, we have, or America, or wherever it is, we have a lead and chase car. And we're able to feed real-time data to those cars via high-powered Wi-Fi to say, well, how the motor's performing, how the battery's performing. So we've got incredibly advanced data, and that also means we can actually control the car. We can set the speed of the cruise when we're going along. So it's really incredible feat there. And, excuse me, we also use a standard CAN bus in our ABS and other electronic components in the system. Now, what about these solar panels? There they are. There they are in question. There's 391 of them. So I won't ask you to count them. I'll tell you there's 391. They're about 24% efficient, and they're silicon-based. So these are probably the most advanced silicon solar cells you can get in the world today that are available. There are other types, gallium arsenide, for instance, that go up to 40% efficiency. We've stuck with 20%. The actual weight of the whole solar array you see there is 5 kilograms, and it's only a millimeter thin. So there's no glass or any extra weight holding us back. It's just those raw panels. And they're encapsulated by a company called Gockerman in Germany using a process that's unbelievable. It actually increases the efficiency for us. We've also got a lithium-ion battery pack on board. We've recently halved the weight of that, but keeping the same energy density. So now actually, while we did have 40 kilograms, we're now moving to 20 kilograms. Makes us lighter, makes us able to go faster for longer. But what about, we built a car. What do we actually do with it? Well, we race it, as I said. This is a CGI of us by Ayers Rock. We'll hopefully go there this year. Pretty cool. And that's Australia, driving all the way down the Stuart Highway from Darwin down to Adelaide. As I said, it's 3,000 kilometers. Well, actually, specifically 3,022. And trust me, the 22 is the hardest bit for us. Darwin to Adelaide, as I said. And it's run every 2 years in the autumn in Australia. Next one's October next year, 2017. We race from 8 till 5. That's a pretty long time to race. Incredible heat. To give you an example, we saw temperatures of 50 degrees centigrade inside the car and on the panels. So our driver, who's the smallest person on the team, well, 3 of them are, they had to clench inside and not touch the carbon fiber while sitting still. That's how hot it was. It would burn you if you touched it. We've got 45 other teams competing, as I said, many of whom, in fact, most of them have 6-figure or more budgets. We've got one of the lower ones, but we do really well with it because we've managed to design and build everything ourselves. And, excuse me, we've also got various different classes of entry. As an example, we run in the Challenger class. That's designed to go as fast as possible for as long as possible. But there's also the Cruiser class, which is a bit less table-like and a bit more car-like, shall we say. Looks a bit more, more like a car. And that's the actual distance we're driving. So we're driving the equivalent of kind of Norway to Greece, to give you an idea, to put it more Eurocentric. So pretty long way. Now here's some of us, a picture of us on the road with a Land Rover Discovery there, Jaguar Land Rover, one of our sponsors. As I said, we run entirely on solar power. We drive from 8 till 5. We camp where we stop. Now, in 2011, we kind of learned a lesson because we had to stop and camp. We decided to camp next to a cattle grid, which went well. You can imagine the noise throughout the night as road trains thunder over it. So the person who chose that campsite was not popular. I think he was sacked the next day. And we're entirely self-sufficient. So we have to we have our own water tanks. We have to have deionized water for the solar cells. We have to have our own food, our own fuel. Everything we have to do ourselves. It's a challenge for the car, and it's also a big challenge for the team. So let's have a look at some of the photos from us, of us there. This is up in the picture. You can actually see some of the Cruiser class cars there, the kind of 2 in the center that look a bit more car-like. So we've got the Challenger class as well there. There's another shot of the cars going down the pit lane. As I said, 45 other teams do this. So we're in the pits in Darwin to qualify. So there's a qualifying round that we enter. And all the teams enter. There's various dynamic scrutineering stages and static scrutineering stages. And that's us in the pit lane getting ready to qualify amongst the team. And another shot there, a nice shot of us of Hidden Valley Raceway in Darwin. It's a great test track and a great availability for us to build things and design things at the last minute should anything go wrong. That's our motor being slotted into the car. You can see the trailing armor and suspension on it and the roll hoop just behind that. So it sits directly behind the driver on the left-hand side. Scrutineering comes along, so the drivers are weighed. There's a very interesting technique, which is basically we want them to weigh we want them to weigh as close to the 80-kilogram ballast that we have. So we have to make sure the driver is 80 kilograms. If they're less than that, they're ballasted up to it. So you can see Ellie there on the right. She was basically force-fed water to increase her weight. So we have various tactics that we employ and other teams employ to make sure that we get every extra kilogram or less kilograms of ballast to put in the car. So we're weighed, we're scrutineered as well. This is us in static scrutineering inside a big hangar that they've got at the test track, and all the other teams are scrutinized on things like your braking distance when you're doing dynamic scrutineering, the design of the car, how many solar cells you've got, the safety systems, fire extinguishers, should anything, God forbid, happen. Everything's checked and proofed there. So it's a very safe event. This is us. We managed to qualify. We did encounter a technical issue with the motor. It is 50 degrees out there, so things do, and it's very humid, so things do short circuit a bit easily, shall we say. But undeterred, we qualified. A lot of teams actually didn't qualify. We were one of a fair few to do so. And this is us actually on the road. This is us driving from Darwin to Adelaide. Land Rover Discovery is flanking us. We had 2 very kindly provided to us by Jaguar Land Rover, as I said. This is us again driving across, so we're in proper desert conditions. You can just about see how sparse and barren it is. It's a real challenge for us. Now, this isn't our car, don't worry. When I first saw this picture, I went, guys, you didn't tell me about this. When did that happen? Now, this is one of the Malaysian teams. They, as I was saying about the battery chemistry, lithium-ion and particularly certain types of lithium-ion batteries are incredibly susceptible to thermal runaway if they're damaged. This is what happened to the Malaysian team. We got a call over the radio saying guys, we've got a major problem. So we sped up, and you have to basically, once a lithium-ion battery fire starts, it's not going to stop very quickly. So we had to shovel sand onto it. We had fire extinguishers that we had to deploy. It was a pretty exciting moment. They managed to actually finish the race as well. They managed to rebuild their batteries, rebuild their systems. All the teams pulled together to make sure they could finish. So a real show of camaraderie there. But an incredibly dramatic sight for us to see. The driver proving that he could get out in the 15 seconds that was the limit. So it's a big challenge for us. We mustn't underestimate the challenge there and the danger. This is us on the road, fortunately not on fire, that we've stopped on the side of the road just to get everything sorted. So we have various checkpoints we have to meet. So as an example, we have to be at a certain place at a certain time to make sure that we are performing correctly. And they check that we haven't been tweaking anything unawares to the observers we have. And this is actually one of the things we have to do whilst there. So when we are on the road and we've camped for the evening, we have to wash the solar panels down. They get a lot of dust on them. That degrades the efficiency. So we have to wash them off, but not using any water, using deionized water to make sure they're clean and have the optimal optical quality that we need to perform at 24% efficiency. Again, these are so fragile. If you touch them, it damages them. So we have to be very careful. We have to keep saying hands off array. So we have to make sure we didn't touch it. It's very, very fragile indeed. This is us camping. Nice evening shot we had as we were settling down for the night. So not too dissimilar to here, I suppose. Camping in the middle of nowhere. Although a few more spiders and snakes and other things as well to get in your sleeping bag. But an incredible an adventure for us. And here's a nice shot of the car on one of the final evenings before we reached Adelaide. And this is us at the finish. We managed to finish. Despite our technical issues, we managed to complete the whole 3,000 kilometers from start to finish. We didn't manage to actually drive all of it, unfortunately, but we still finished, which is a big feat. Next year, we're going back and going to be the first ever UK team, we hope, to go from Darwin to Adelaide entirely without stopping, without any malfunctions. So set us a big goal because no team has ever done that from the UK before. Again, this is us right at the finish line. It's a big event. It's held, as I said, every 2 years. I think it's been going since about the 1980s when a couple of drunk Australians said, let's go and have a bit of fun with solar panels and see how fast we can go because it's hot and sunny. So it's been going for a number of years, this event, but it's really grown to be the premier solar race. What about other things we do? We do other events. We want to showcase our technology to you guys. Now, the car's not here, obviously. It's back in Durham being fixed and being worked on and enhanced. But we take this to major events. So we get huge publicity because people go, what on earth is this thing? Why is there a table with solar panels on it? Or why is there what was the other one? They said a boat. People think it's a boat. This is us meeting Prince Michael of Kent and Sir Nigel Mansell at the London Motor Show. That was a big shock for me because I was chatting to the stand next to me. I wasn't told that they were coming around and managed to miss him on the first attempt, but then he came over and had a very nice chat with us about the car. So, very nice stripe. And I don't know if you recognize this guy. You're probably more used to seeing him with a white suit and helmet on. That was the Stig, Ben Collins. He came along and was very keen to see our car and find out more about it. Again, I didn't recognize him until he actually introduced himself as who he was. So, it was pretty exciting to see him. That's myself talking to Tiffany Dale. That's probably when I told him about that reaction he's got. It's probably when I told him about the Malaysian team and the fire they had. I rather like that shot of him and I doing a Q&A there, not too dissimilar to this kind of environment, actually. It's coming back next year as well, so keep an eye out for it. We'll be back next year, hopefully, as well. We were then really excited because we were invited off the back of that to come to probably the biggest motor event in the world, Goodwood, the Festival of Speed there. To give you an idea, that had 68 million people hear about it around the world. That's just one event. Hundreds of thousands came and saw us. That's the sculpture there by BMW. We had a stand there that we managed to get. This is the car there, attracting a great deal of interest. It's a really, really cool bit of kit as we built a new canopy for it as well. And that's our stand there representing Durham University and all our sponsors. So we see huge reach and we see huge interest from all ages. And by all ages, particularly referenced as last week, week before last, was it last week? It was last week. We were at the Science Museum. We actually exhibited for 3 days there as part of their Antenna Live event. And we were featured on a number of programs in the London area. So we get really big interest from kids going, how on earth does this thing work? It's massive. It's an incredible feat of engineering. And I know, for example, our team principal saw Durham solar car, that Jetson-looking one in 2004, 2008 time, and now he's team principal and now has gone on to it. So he's been hugely inspired. Just to quickly recognize, these are the list of sponsors that we have. So a variety of small and large companies. Climb Online, as an example, recently signed. You probably might have heard of a guy called Lord Sugar. His apprentice, Mark Wright, the Australian chap who founded a digital marketing agency, he's building a new website for us. That's an incredible new sponsorship deal we signed. We also have Jaguar Land Rover and a series of others. So, and we continue to look to expand for this. Some of them like connecting with us engineers and offering them jobs. Others like inspiring the next generation. And others like saying, here's some technology, go and show how good it is. So as I said, this car does 70 miles an hour. It weighs 200 kilograms and uses 5 times less power than a Toyota Prius. But what's next? That's the past. What about the future? Well, I won't go into too much detail because there's a lot of things we're working on that I can't yet mention, but we've got a very exciting future ahead. We've got all the events coming up, leading up to Australia 2017, going back to Australia, racing all the way across the outback. We look forward to welcoming a lot of people to see us at future events, and we're very excited about what's to come. Very, very excited indeed. And I hope you can see that our new values that we've come up with of showcase, educate, and inspire are truly shown by myself and others members of the team, and indeed the car that we've designed and built from scratch. This was a toil, a labor of love that we were up till 4 a.m. most mornings getting it ready. Most of the guys didn't sleep while they were in Australia. The team principal told me I had the best flight back. I said, why is that? He said, well, I slept for the whole 13 hours. So pretty much from Malaysia to London. He said, I remember going to bed, I was falling asleep just as the plane took off, and then next thing I know, I was in London. So he had very little sleep over the entire race. It's a really grueling challenge. But we are very excited to be going back there next year. I think I've just finished on time, which is good. I won't do any Q&A on the stage. I'll just be down at the front. If you want to come and ask me any questions about the technology we've done, the events we've attended, what's coming up, any questions whatsoever, I'm more than happy to answer them. And if I can't answer them, then I'll give you the team's contact details and you can get in touch with them. So thank you very much indeed for listening. It's an honor to be here, privilege to be here. Hope you enjoy the rest of the event. And thank you very much again.